All right, Algebra 1, let's talk about parallel and perpendicular lines. Page 319. This is 5.5 in your book. 319. Let me turn my board on. Hold on, it turns off on me sometimes. I know it's hard to believe I have trouble with that board, huh? Okay, 319. First off, we have some vocabulary and a key concept box, so we can kind of kill two birds with one stone. So here we go. Converse. It's not a name of a shoe, right? Those old basketball shoes, the Converse shoes, or even, they're not really old. Sometimes there's still some people wearing them. Converse, on the top of page 319 says, the converse of a conditional statement interchanges the hypotheses and the conclusion. The converse of a true statement is not necessarily true. So it is when you change the hypothesis and conclusion of a statement. And we'll do that here in a second with the key concept box, okay? Parallel lines. Parallel lines are lines that will never cross. Okay, a conditional statement, and that is goes way back. It's like an if-then statement. Okay, if you save your money, then you will have enough to buy the bicycle that you want. Okay, those are conditions. It depends on the conditions. Perpendicular lines are lines that do cross, and they cross at 90-degree angles. Okay, so we'll be doing those. Let me see if I did a key nope, we'll go back. Key concept. Parallel lines, there is a statement there. They have two of them actually. They're converse statements. Listen carefully. If two non-vertical lines in the same plane have the same slope, like the same plane would mean you're drawing them on your piece of paper, there's not one that's out there in 3D land somewhere, then they are parallel. So if they are in the same plane and they have the same slope, they are parallel. And then if two non-vertical lines in the same plane are parallel, then they have the same slope. Both of those are true. If they are parallel, they have the same slope. If they have the same slope, they are parallel. So write that down, and let's tackle example number 1. Write an equation of a line that passes through -3, -5, and is parallel to the line y equals 3x minus 1. Well, what do we know about parallel lines? We know that parallel lines have the same slope. Okay, so that we want that slope, but this one crosses at -1, but the other one, if it's parallel, is not going to cross at -1, so we do not know what b is going to be on our new line. So we have y equals 3x plus b. That's all we know for our new line, is that it has the same slope as the given line. Okay, so what else we know about our new line is it passes through this point. So we know the x and we know the y. So put in what you know. -5 for the y. 3 times -3 plus b. Trying to find that new b. Simplify. Equals -5. We're going to add 9. Add 9. 4 equals b. So our new equation is going to be y equals 3x plus 4. That line's going to be parallel because it has the same slope, and it's going to go through those points. Or excuse me, that point, because we use that point to find the y, where it crossed the y-intercept, the y-axis. Let's see if they agree with us. Slope-intercept form, put in our slope, they put in the numbers just like we did, and as long as my algebra is good, yeah, there we go. It's correct. So write an equation of a line that passes through -2, 1 and is parallel to the line y equals -x plus 5. So the only thing we need this for is our slope. The slope is -1. So y equals -1x plus b, and now let's put in and find our new one. This is 11. -1 times -2 plus b. Two negatives make a positive. -2, so 9 equals b. So y equals -x plus 9. Same slope, and it's passing through that point. There we go. Determine which of the lines, if any, are parallel or perpendicular. Okay, so let's talk about perpendicular a little bit here. Before we do example number 2, I want you guys all to look at page 320, the top of page 320. There are some pictures. Number 1, perpendicular and parallel. It talks about the slopes and the different things about them. So here's our key concept. If two non-vertical lines in the same slope, the same plane have slopes that are negative reciprocals, then the lines are perpendicular. If two non-vertical lines in the same plane are perpendicular, then their slopes are negative reciprocals of each other. And we did talk about this a little bit. Negative reciprocal means this. If you have a slope of 2, the negative reciprocal, 2 over 1, the negative reciprocal would be negative 1/2. So the perpendicular line would be the negative reciprocal. So let's take a look at these. Here's a line. Remember, the determining whether they're parallel or whether they are perpendicular is comparing the slopes. So I can't tell because I don't know what the slope. This one I know the slope is 5, but this one is not in the right form. So let's go ahead and get this over here. I get 5y equals 2 minus x divided by 5. Y equals, I'm going to go ahead and divide that out, 2/5 minus 1/5 x. So this one has a slope of 5, and this one has a slope of negative 1/5. Those are negative reciprocals of each other, so those lines are perpendicular. Line C, so A and B are perpendicular. What about C? Let's find its slope. Negative 10y minus 2x equals 0. Add 2x, negative 10y equals 2x, divide by negative 10, divide by negative 10y. That reduces to negative 1/5 x. So B and C, so A and B are perpendicular, A and C are perpendicular, and B and C are parallel because their slopes are the same. So they're going through, wrote the slopes for all of them. That's what you got to do to compare them. That's what they're doing. Let's see what they came up with. B and C are parallel. A has a slope of 5, and yep, that's what we came up with. Determining our parallels. Let's look at these lines. There's 3 of them. All right. This one we know the slope, so we don't have to do anything with it. It has a slope of 3. This one we have to minus 2x minus 2x, 6y equals negative 3 minus 2x divided by 6, negative 1/2, can't read that very good, minus 1/3 x. So negative reciprocal of that one. This one, minus 4.5x minus 4.5x, negative 1.5y equals 6 minus 4.5x, divide by negative 1.5. The one I only really care about is this one. It's going to be a positive. How many $50s are in 450? Right, over, and up 3. So positive 3 is the slope. So this one has a positive 3 and this one has, so B and C are parallel and A is perpendicular with B and C. B and C are perpendicular, parallel, B and C, okay, perpendicular, A and B and A and C. Okay, the state flag, Arizona state flag is shown in a coordinate plane. Lines A and B appear to be perpendicular. Are they? Where in the heck are those lines? A and B. Can't see it very good right there. Is it If they are, they have the same slope. So they meet right here. That one has a point right there. So let's see, what are those 2 points? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. That's 0.64. That looks pretty cool writing on that. This one is 1, 2, 1, 2, 3, 4, 5, 6. This one is 2, 6. So 2, 6, and 6, 4. So let's find those slopes. I should have written them on top of each other. 6 minus 4, 2 minus 6. Negative 1/2. Now, which is true? It's a negative. This one, let's see, there's a point right there. 7, 8, 1, 2, 3, 4, 5, 6, 7. That's 8, 7. So 8, 7, and 6, 4. 7 minus 4, 8 minus 6. That's going to be 3 over 2. Which is not, and it's positive, that's not equal. I say no unless I counted wrong. They did something way different than what I did. They're not negative. I just counted the points on the graph. They wrote out equations of the lines, so I think if it's a picture and you can get away with that, that'll work. All right, example number 4. Write an equation of a line that passes through 4, -5, and is perpendicular to the line. All right, so remember, perpendicular, we need the negative reciprocal. So if this one is 2, the negative reciprocal of 2 is -1 over 2. So that's the slope we need to use. So y equals -1 over 2x plus b. Put in 4 for x, put in -5 for y. It's just like what we were doing with the parallel, it's just we used the negative reciprocal. 1/2 of 4 is 2, so that's -2. -5, add 2, -3 equals b. So our equation would be y equals -1/2 x minus 3. We're going through all the work that we went through. Exactly the same thing. And then wrote the equation. 1/2 x minus 3. Is line A perpendicular to line B? Justify using slopes. Okay, the slope, I don't know the slope of either of them to start with because they're not in the right form. So minus x, I get 2y equals -12 minus x, divide by 2. Y equals -6, and there's a 1 minus 1/2 x. Notice I don't divide that out, I leave it because I need it rise over run for slope. Divide by 2. I get y equals 3/2 x minus 4. No, those are not negative reciprocals of each other. So again, the slope, we want it perpendicular. So it needs to be, if this one is 4, we need the negative reciprocal of that. So y equals -1/4 x plus b. Let's see, 3 times 4 plus b. My 4's are going to cancel out. That's a -1, right? Yep. So add 1, add 1. 2 equals b. So y equals -1/4 x plus 2. Plus 4. Oh, plus 1. What's 3 plus 1, everybody? Even had it written right. All right, I guess. Darn, I was just having fun. I guess that's it. Remember, parallel, the slopes are the same. perpendicular, they are the negative reciprocals of each other.